Okay, hi, this is John Marsh. I'm here doing some homework problems for NCS 210, and I'm doing some from chapter 3 of Forouzan, and I'm going to do problem 3.2. And here they give us the period, and they want us to calculate the frequency. And so I'll label this as 3.2. I'll say given the period T, calculate the frequency F. Okay. These are straightforward, but give me a nice way of illustrating our problem-solving techniques. So on part A, we're given the period is 5 seconds, and we need to calculate the frequency. And so I'm going to write that the frequency is 1 over the period. This is a lot like the problem number 1, where I had the period is 1 over the frequency, and I can just invert that equation to give me the frequency is 1 over the period. They're inversely proportional, in other words. Okay, so I'm going to go ahead and plug in the 1/5, and I'm going to get a 0.2. And because I plugged in the 5 had units of seconds, this 0.2 is going to have units of hertz. And I think I'm just going to leave it like that. I could write 0.2 millihertz, but we don't normally have signals that slow, and so I'm going to leave it as you hardly ever see a millihertz. So I'm just going to leave it as 0.2 hertz. For part B, the period given is 12 microseconds. And I'm going to immediately turn that into seconds by going 12 times 10 to the minus 6 seconds. And then F is 1 over T, 1 over 12 e to the minus 6. So take your time when you do these problems. Write the equation, then write the numbers plugged into it, and then enter it in on your calculator. And let's see, for this one I got 83,333. And I'm going to go ahead and write it as 83,300. And then the answer on this one's going to be hertz, because I converted this period into seconds before I plugged it in. I'm not going to write 83,333. I'm just going to keep 3 digits of precision here as sort of a general rule for this course. And I can then move the decimal place over 3 places and get 83.3 kilohertz. Okay, kilohertz means thousands of hertz, 83,000 hertz, which is what I had there. And finally, the period is given here as 220 nanoseconds. And again, we're just plugging in these problems. Again, I'm going to write 220 times 10 to the minus 9th. I'm going to turn the nano into a 10 to the minus 9th. So this thing now has units of seconds, and I can plug it right into this equation like this. And if you plug that in on your calculator, you're going to get 4.545 times 10 to the 6th hertz. And times 10 to the 6th hertz means megahertz, so it's 4.545 megahertz. Okay, and on all of these, I'm going to, sort of double check here. If the period is 5 seconds, then it is 0.2 per second, 1/5 of a period per second. That one sort of makes sense. Here we have quite a short period, and I get a pretty high frequency. So something like 10 microseconds would give me 100 kilohertz. Here now I have even shorter period, and so I better get a higher frequency. Here I had a period of microseconds, here I have nanoseconds, so I better get a higher frequency for part C than I did for part B, and indeed I get megahertz rather than kilohertz. So it sort of checks out.